Hey, welcome back. I just wanted to take a little time to finish introducing this whole new format of instead of me giving you an ordered pair for a complex number, we're using this x plus yi form instead. X plus yi has a real part and an imaginary part, and it can be converted. And what we've been trying to do in number 1 and 2 is convert it to an r cosine of theta plus I sine of theta. This is the nickname that we gave to that notation, r cis theta, and it can always be typed in the long way too, right? Cosine of, in this problem, we got 4 pi over 3 plus I sine of 4 pi over 3. And we were kind of lucky in 1 and 2 to get some tangent values that were recognizable to us to get a nice, easy, exact value answer, like tangent is square root of 3, we recognize that. Tangent is -1. That was easy to recognize as well. Well, that won't always happen, and if you have your calculator handy, I wrote another one. I just boxed it off to the side here at the bottom of Polar Packet page 13, and I picked a quadrant 2 angle. Convert to polar form, random numbers, -2 plus 7i. The very first thing we did in 2 and 3 was to establish which quadrant that we're going to fall in, because we want to make sure that our answer is going to fall over 2 to the negative realm on the real axis and up 7 on the imaginary. Well, you'd still start the problem the exact same way. R is still going to equal, according to Pythagorean theorem, plus or minus the square root of this squared, so -2 squared is a 4, plus the b squared, or plus the y squared, which is going to be 7 squared is 49. And you get an exact r value, and I'll try to keep it positive, of, we'll say 53, right? Okay, now we need to be wise and use the calculator to help with choosing a theta value. Tangent of theta still equals y over x, so 7 over -2. There are 2 quadrants where this is going to happen, right? A, S in the second quadrant and in the C in the fourth quadrant. I'm interested in getting a solution in quadrant 2 because of the way that we graphed this originally. So I'll go to my calculator. I'm going to answer in radians because that's what I'm most used to. So mode, I'll make sure I'm in radian mode. And I'm going to take the inverse tangent, not of -7/2. I use the negative to get the picture and figure out what quadrants are possibilities. I'll just take the inverse tangent of 3.5, of 7/2 positive. This gives me a reference angle. Your reference angle is the acute angle from the terminal side down to the x-axis, and here to the nearest thousandth, it's going to be 1.292. That means I can squeeze that in here. 1.292, whoops, 92, very sloppy, is going to be your reference angle. Let's say theta is going to equal, well, you didn't go all the way to pi. You're coming back that reference angle. In quadrant 2, let's do pi minus about 1.292. That should help with theta. And I ended up just leaving this as a nearest thousandth decimal, a 1.849. Theta is about 1.849. That is a quadrant 2 angle, which leaves the door open for me to use a positive r value. Very important how you leave your answer, right? WebAssign would want it all spelled out. So r cosine theta plus I sine theta. So square root of 53, cosine of that approximation, so 1.849, plus I sine of 1.849. It's not hard to write it out. It's just a lot to write out. So if this is you on paper just taking your notes, I recommend just using cis. So we'll go abbreviation cosine plus I sine CIS and the approximation 1.849. So we've seen a couple examples now where we knew an exact value, and then at least one where the calculator was useful. Okay, I think if you thought that was okay, you're going to love 3 and 4 because converting from polar to rectangular is even easier when you're talking about complex number form. Watch what I can do here. I could ask you the same question in 3. I could say, let's be wise about this. Let's figure out what quadrant we're in off the bat. Well, what quadrant does 7 pi over 6 fall in? This means r is this value here, 2 square root of 2, and theta happens twice. Theta is going to be 7 pi over 6. Theta falls right past pi in quadrant 3, right? And we want a quadrant 3 solution. Well, these look like things we can simplify on our own. Can we try this? It'll be 2 square root of 2. This is not me putting any new equations or expressions in here. I just want to evaluate the cosine of 7 pi over 6. That's what I want to try now. Think about the cosine of 7 pi over 6. We're in a quadrant where cosine AST, cosine's going to be negative, so I know this value is negative. 7 pi over 6, you're going out further than you're coming up. So it's negative square root of 3 over 2. plus, don't forget the I. The I is part of it. It's a crucial part of it. And then sine of 7 pi over 6. Well, the sine of the same angle, 7 pi over 6, is still negative, and it's only negative a half, like that. Believe it or not, we're converted. There's no more r's and thetas in here. There's only expressions that can be interpreted as x and y. We want to simplify and just get rid of the parentheses as our final step, but I just think this is so nice because you're just writing exactly what values you know these things to be. So the 2's will cancel here, and you'll get negative square root of 6. And then I still need this whole thing multiplied by that second fraction where the 2's will cancel here, and it'll be minus I square root of 2. This is your complex number in rectangular form. What's x? X is this value here. X is negative square root of 6. What is y? It's negative square root of 2. I love getting both negatives when I wanted that answer to fall in quadrant 3. That looks like it's good to go. Can we try 4 to round things out? So I would just recommend simplifying everything that you see here to just make it magically become a complex number in rectangular form. So I'll leave the 2. We need to think of where negative pi over 3 lies, so we can be cognizant of the signs, SIGNs, of our trig functions. The cosine of negative pi over 3, so now I didn't really draw this to scale. You're at pi over 3 reference angle where you're going out a little less than you're going up or down. So the cosine is going to be positive in quadrant form. I'm going to say positive a half for that value, plus I sine, and then negative pi over 3, so it should be negative square root of 3 over 2. Okay, getting rid of the parentheses should do the trick, and we can call this one a day. So it'll be 2 times a half is 1, minus the 2's canceling, I squared of 3. And that is your rectangular form. A positive x, a negative y of negative square root of 3, like I would have predicted to land in quadrant 4. If for some reason you come across a problem when you're practicing and there's not an easy exact value in here, if it's an angle in degrees or radians, that's not something we have memorized, that's where the calculator comes in handy. And the problem will tell you to round your solution. But this can just be typed in and you have your rectangular form. All right, enjoy your day. See you soon.